Now I'm going to discuss you this type 2, how to form a partial differential equation by eliminating an arbitrary functions. Suppose the equation is given in this way as phi of uv is equal to 0, where uv are function of xy and z is also a function of x and y. Now let us solve this example so that will be more clear with this method. So form a partial differential equation of this function phi of x plus y plus z, x square plus y comma x square plus y square plus minus z square is equal to 0. So let us take u to be this one, x plus y plus z, and v is equal to x square plus y square minus z square as v. Now this equation star becomes what? It will be phi of uv is equal to 0. We name it as equation 3. So on differentiating this equation 3 first with respect to x partially, what we'll get as phi is a function of uv, but u and v are function of x, y and z. So what you will get from here by differentiating this one partially with respect to x, so you will get it as del phi del u, differentiate first phi with respect to u, then del u del x plus, since u is also a function of z, so it will be del u del z into, but what is z? We know that z is a function which depends on x and y. So it will be del z del x plus, now for the second function, that is v. So it will be del phi del v into del v del x plus del v del z into del z del x. So this will be equal to 0 because the right hand side is equal to 0. So on differentiating 0 with respect to x, it will be 0 again. So what we have now is this equation. But from equation 1, what is del u del x? What is del u del x? You can calculate from here del u del x from this equation 1. It gives you 1. Y and z will act as a constant. And what is del u del z? Del u del z also is equal to v in this case. And then what is del v del x from equation 2? It is 2x. And what is del v del z? This is equal to minus 2z. So let us substitute this in this equation. Let me name it as equation 4. So therefore equation 4 will implies what? Del phi del u will remain as it is. Del phi del u into del u del x, it is equal to 1 plus del u del z, it is 1 again. But what is del z del x? Del z del x has to be replaced by that. It will be 1 into p because we denote del z del x as p. Then plus del phi del v into, what is del v del x? It is 2x. And what is del v del z? It is minus 2z. So here it will become minus 2z into del z del x, that is p. So this is equal to 0. So let us simplify this one. You'll get del phi del u into 1 plus 1 into p. This will be equal to minus del phi del v into 2x minus 2zp. Transfer this one to that side. Now you divide through, this one on both sides by del phi del v, and then this also you cross multiply to this side. This one to this side, you will get it as del phi del u upon del phi del v. This is equal to minus 2x minus 2zp divided by 1 plus p. So name this as equation 5. Now next, differentiate again this equation 3. Now on differentiating 3 with respect to y now. Differentiating 3 with respect to y. What we have now, what is this function? Just like in the first case while differentiating with respect to x, so you'll get in this way del phi del u into del u del y plus del u del z into del z del y plus differentiate this one phi with respect to v first. It will be del phi del v into it will be del v del y plus del v del z, as v is a function of z, then and z is a function of x and y, so it will be del z del y. This is equal to 0. But now let us see what is del u del y from equation 1. From equation 1, del u del y, if differentiate this equation 1 with respect to y, you'll get it as 1. What is del z del y, or del u del z? Del u del z will be equal to 1. And then next from equation 2, what is del v del y? It is 2y, and del v del z is equal to minus 2z. So substitute these 4 values in this equation, then you'll get del phi del u into del u del y, it is 1 plus del u del z, that is del u del z, it is 1 into what is del z del y, we denote it by q, plus del phi del v into del v del y. Del v del y, it is 2y, plus del v del z. Del v del z is minus 2z into del z del y. Del z del y, it is q. So this is equal to 0. Just like in the first case, we transfer this term to that side. Then you'll get del phi del u into 1 plus q is equal to minus del phi del v into 2y minus 2z cubed. Now simplify this one further by cross multiply this term to this side, then you'll get del phi del u upon del phi del v. This is equal to minus 2y minus 2z cubed divided by 1 plus q. So name this as equation 6. So what we have from equation 5 is this one, and from equation 6 this one. So in order to eliminate this function phi here, what we need to do is, because we need in this particular case we need to eliminate the function phi. So you divide this equation 5. 5 on dividing by 6 will implies what? It will be del phi del u divided by del phi del v. Then divided by the left hand side of this equation 6, it is same thing, del phi del u del phi del v. This is equal to what? What is the term on the right hand side of this equation 5? It is minus 2x minus 2zp divided by 1 plus p, whole thing divided by the right hand side of this equation 6, that is minus 2y minus 2z cubed divided by 1 plus q. Now you can see that this and this can be cancelled, and then minus sign can be cancelled. So this term will come to the if you cross multiply this one, then will come 2y minus 2z cubed divided by 1 plus cubed is equal to 2x minus 2zp divided by 1 plus q. You can further simplify, cross multiply this one to this side and this to this side, then you'll get the required partial differential equation. But what we notice from here is that this partial differential equation involves this one p and q only, where p is what? P is del z del x and q is del z del y. So the order of this partial differential equation now will be equal to 1, because the order of this is equal to 1. Hope it is clear with this problem. Now let me come to this problem. Next problem, how to form a partial differential equation by eliminating these arbitrary functions f and capital F. So here given set is equal to, it is given set is equal to fx plus iy plus fx minus iy, where I square is equal to minus 1. Now set is equal to this one, name it as equation 1. So what differentiating 1 partially with respect to x and y, we have, so if you differentiate it partially with respect to x, then what you'll get now, it will be del z del x is equal to, if you differentiate f, then it will become f prime of x plus iy into the differentiation of the term inside the function, that is ddx or del x of x plus iy. So it will be del x of x plus iy plus differentiation of f will be f prime x minus iy into the differentiation of del x of x minus iy. So simplify this one, you'll get del z del x is equal to differentiation of x plus iy will be 1, so you'll get f prime of x plus iy here, plus in this case differentiation of x again will be 1, and then 1 into this, it will be f prime of x minus iy. Name this as equation 2. Next, on differentiating it partially with respect to y, then what you will get, del z del y will be equal to differentiation of f here will become f prime of x plus iy into the partial derivative of the term x plus iy. So it will be differentiation of x will be 0, differentiation of iy will be I, into I you will get here, plus f prime differentiation of this will be f prime of x minus iy into the partial derivative of x minus iy. Differentiation of x will be 0, but iy will be minus I. So it will be minus I. So this, on simplifying, you'll get it as del z del y is equal to f prime of x plus iy. I will be there, then minus I f prime of x minus iy. Name this as equation 3. Again, you differentiate this equation 2 with respect to x. Differentiating this equation 2 with respect to x, then this side will become del 2z del x2. That is a second order partial derivative with respect to x. So if you differentiate this one, it will be f double prime of x plus iy, and the differentiation of x plus iy, that is differentiation with respect to x, will give you 1. So it will remain as it is, plus f double prime of x minus iy. Again, if you differentiate this one partially with respect to x, then you'll get 1, and so this will be the partial derivative of the second order with respect to x. So name it as equation 5. Next, you differentiate this equation 3 again now with respect to y. Then what you will get from here is that del 2z del y2. If you differentiate with respect to y, so you will get here I square, because differentiation of x plus iy will with respect to y will be I will come out, so I into I will become I square, so f double prime of x plus iy minus this one I into minus I will come out from here, so minus I into minus I, so it will become I minus into minus will become plus, so it will become I square, then f double prime of x minus iy. So this is equation 6. Now, after getting these two equations, 5 and 6, what we can do now? Okay, you can simplify. What is I square? It's given that I square is equal to minus 1 in the question. So this will become minus f double prime of x plus iy, and this I square will become minus 1, so you'll get minus f capital F double prime of x minus iy. So let me name this as equation 7. So from here, let us add this equation 5 and 7. On adding 5 plus 7, the left hand side term will give you del 2z del x2 plus del 2z del y2. Now what will be the term on the right hand side? See, I have here in equation 5 f double prime of x plus iy, but in equation 7 I have it as minus f double prime x plus iy. So that means this and this will be cancelled. Similarly, the second term, in 5 it is capital F double prime x minus iy, and in equation 7 we have it as minus f capital F double prime x minus iy. So this and this one can be cancelled. So that means the term on the right hand side will be 0. So this is the required equation, a partial differential equation, by eliminating the two constants, by eliminating the two arbitrary functions, small f and capital F. Hope now it is clear with this type 2 how to eliminate the function, arbitrary function from the given equation in order to form a partial differential equation.